We're going to do this question 2 on set 2 of a Stanford mathematics problem. It reads as follows. A faded bill was found which read 72 turkeys, blank 67, 90 blank, dollars. What are the missing digits and what was the price of one turkey? Take a couple seconds to try this out for yourself. Then we'll use some hints, then we'll get on with the proof. Alright, for some hints, you're supposed to just try to get as close as you can to certain numbers and to see what 72 turkeys or 72 units will give you. Alright, let's begin. So trying to figure out what our units will get us close to is the idea of saying, hey, well, if a turkey was $1, this entire bill would be $72, but clearly that's not true. But if you start listing them out, you want those that are close to $67, since that's like right on the dollar. So if you're around that much on the dollar, you can use the change to round up to get to the full $67. So let's see. Maybe if they're $1, you should be 72. You can get 144. You get 360. You can get 648. And you get 864. And these are all the ones that are reasonable multiples of $72. That is, if they cost $1, it would be 72. If it cost $2, it would be 144. We're choosing ones that are close to 67 in the sense that 44, 60, 48, and 64 are relatively close to $67. But let's figure out what the missing was. So if they were $3, they'd be 360, for instance. Or if they were a little more, they'd be $864. So let's figure out what's missing to figure out what the change has to be. Well, for 144, you need an extra 23.90 something in change to make it up to 167.90 something. For 360, you only need to go up by $7.90 something cents. For 648, you need to be going up from 48 up to 67, you need to go up $19.90 something cents. And then for $864, you need to only go up $3.90 something cents. Cool, well, now we've got a list of prices. How do we use this? Well, the fact is, recall that each of the cents is going to be multiples of 72, because each of them is, whatever price it is, you need to multiply 72 to get the full price. So if we just look at these, 79 is kind of close to 72. Well, it's off by a 7. Well, what if 72 plus 7.2 will give you 79.2? And if you just shift the decimals over, you can get 792. Well, that works here. Does it work for any other? Well, 23.9 divided into 72 pieces is a little small. It's around a third, and it doesn't work perfectly. 19.9, well, we've seen that we get 800. We can go 864 plus another 72 will give you a total of 936, and if you double that, you'll be around there, but you'll be too close. You'll be around 1800, 600. And finally, for the 39, we've seen that if you remember, we can only get up to 360. And the difference there is only 30, which will not be satisfied by the 72. So you see, this is the only one that works. In particular, what does the change have to be? Well, we need to get to $360. So how many 72s is that? Well, 360 divided by 72 is 5. So each one is worth $5. And the remaining $7.92, well, is 10 cents to get up to $7.20, another 1 cent for the remaining 72. So each of them costs $5.11. So we can check that works. That $5.11 times 72 turkeys will give you $367.92, which will in fact work. With that, the missing digits are 3 and 2. Thank you for watching.